Well, hello everyone, and today in this video we'll be seeing one of the problem from Geeks for Geeks. It says remove BST keys outside the given range. The problem is pretty simple. We are given a root of a binary search tree and two integers L and R, uh, and we are asked to remove all the nodes whose value lie outside this range. Note the modified trait should also be BST. Cool. So it's in BST, which we have been provided. We have left and right nodes, or we can say range. And beyond this range, we wanted to remove. So minus 10 and 13. Minus 13 lies beyond this range because it's way minimum. We lie with 6, minus 8, and something like this. Cool. So how we can understand or how we can remove these things? Like one thing is for sure, it's a BST, so things can be simpler for us. So we know that the current, and this is lesser number onto the left and greater number onto the right. So whenever we wanted to remove any number outside, then what do? So first of all, do we have to remove if outside range? So remove any number which is outside. So if and only if range, if only if it's outside the range, then only we are going to remove this thing. And how we are going to remove? If it is outside, there might be two possibilities. One is current is greater or current is lesser. So in this case, if the current is greater, we want lesser number, and to find lesser number we will go to left, and here would be a quite opposite case because here we want greater, because current itself is lesser. We don't want lesser numbers again because we are facing the lesser number dilemma, and we want to go to right to get the greater numbers. And hence, as soon as we will go, we will get the nodes from each of them, or I'll say valid nodes which are within the range. And once we are getting valid nodes, we will get, or we will assign them to left and right. Assignment based upon valid nodes. And once we get, we return the parent or current node, because current node was within the range. That's why we went ahead to check for the, sorry, because we wanted to get a valid node and return that. So now let's implement this algorithm and things would be much more clearer. So if root is null to me, I would return null. That would be our base case. And there's a chance that, hey, if the root dot data is lesser than the left, or root dot data is greater than the right, that means current root is for sure out of the range. I would just mention the range here. So if it's outside of the range, we won't take current, and in this case check for left or right. So if we know that when to check for left and when to check for right. So if current data, which means root dot data, is greater than the right node, then we want a lesser number, and to get lesser number we will go ahead to left. So I'll recall this function tell to get valid nodes from left, keeping left and right range as same. Else we wanted greater numbers. And to get greater numbers, I wanted to go to right. Makes sense. But what if my current node is valid? So in this case, I am choosing current node. So I'll take node current is equal to new node root dot data. And if I'm creating a new node as current, I wanted to set its left and right. So setting child. So how do I set the child? I would go ahead and I would remove all the keys from my left child root dot left, keeping the range in mind. And similarly, I would go ahead and for my right child, I would go ahead and remove all the nodes which are outside of the range for my right subtree. When that is done, I would return a valid node which is correct. And that's it. Nothing much, not a very big rocket science. This is what we have mentioned, left and right assignment based on valid nodes. So I'm getting valid nodes from this method, and this method is ought to give me valid nodes, and ultimately we will return the current. So let's compile this for checking any of the compiler errors. So it compiles well. Let's submit this for any for the rest of the test cases. And yeah, so this is yet another typical example from BST. Here we can go ahead and create a new BST, but that would be a new problem among itself. But if you wanted to know how to create a binary search tree from an array, click the video on your right and I'll see you in the next one.